The James Webb Telescope has begun delivering unprecedented images, but also uncomfortable truths revelations that are challenging the foundations of modern cosmology and forcing us to whether we truly understand how the universe was formed, whether we are alone in it, or whether we have simply been looking in the wrong direction. What you will see in this video is not science fiction. It is the reality revealed by the most powerful telescope ever built by humanity, whose findings have left the entire world in a state of awe. Located more than 28 billion light-years away, at a time when the universe was just 900 million years old, Eridani has become the farthest star ever observed. Its discovery not only represents an unprecedented technological feat, but also a direct challenge to established theories about what we believed was possible. It was detected thanks to the gravitational lensing phenomenon, which magnified its light more than 4,000 times. This star is not an optical illusion or a misinterpretation of a star cluster. The James Webb Telescope confirmed its existence with extraordinary precision. Eridani is a Type B star, a blue giant, with an estimated temperature of up to 16,000 degrees and a luminosity millions of times greater than that of the Sun. However, what most surprised scientists was its composition. It does not correspond to a population 3 star. Those first stars formed exclusively from hydrogen and helium, indicating that heavier elements already existed in that early era of the universe. This directly contradicts traditional cosmological models. But what has generated the greatest impact is not billions of light-years away, but right here in our own cosmic neighborhood. The James Webb Telescope turned its gaze towards Saturn and its moon Enceladus, and the results were astonishing. Emissions of materials were detected that go beyond simple jets of icy water. True geysers containing phosphorus, carbon, hydrogen, oxygen, nitrogen, and sulfur were identified. In other words, the 6 essential elements for life as we know it. Furthermore, phosphate compounds fundamental to DNA formation and cellular metabolism were found. This positions Enceladus as the place with the greatest potential to harbor organic life in the entire solar system. For this reason, NASA has begun accelerating the development of a robotic mission capable of drilling through the ice and exploring its subsurface ocean. While expectations grow for Enceladus, the results from exoplanets bring disappointment. The TRAPPIST, one system once promising for its 7 Earth-like worlds, has begun to reveal its true nature. The James Webb Telescope has already analyzed the 2 planets closest to their star, and the findings are not encouraging. They lack a significant atmosphere. They are hot, barren rocks similar to Mercury, with one hemisphere permanently exposed to stellar radiation and the other in perpetual night. The planet TRAPPIST, 1C, initially considered one of the most promising candidates, also shows no signs of a viable atmosphere, drastically reducing the possibility of finding liquid water on its surface. Despite having a size similar to Earth's and being located within the potentially habitable zone, the absence of an atmosphere classifies it as an inhospitable, lifeless world. The now is whether the other 5 planets in the system will present different conditions, or if all systems similar to ours are destined to be empty, inert spaces. As if observing solitary stars or exoplanets weren't challenging enough, the James Webb Telescope delved even deeper into the cosmos and captured an image that seemed straight out of a digital simulation, a filament of the cosmic web, a structure more than 3 million light-years long connecting galaxies when the universe was just 830 million years old. This is the first time this cosmic web, a theoretical structure whose existence had been predicted but never confirmed with such detail, has been directly and clearly observed. Within that filament, the telescope detected something that shook the astrophysical community: a supermassive black hole, more than 9 million times the mass of the Sun, growing at the theoretical limit allowed. This cosmic seed shouldn't exist yet. According to current models, the universe hadn't had enough time to form an object of such magnitude, and yet there it is, shining brightly, consuming matter at an accelerated pace, as if aware it is being observed. One of the main objectives of the James Webb was to analyze the chemical composition of exoplanet atmospheres, and the findings have been as revealing as they are perplexing. In worlds like WASP 39b and K218b, complex organic molecules have been detected, along with confirmed traces of carbon dioxide, water vapor, methane, and even hydrogen sulfide. However, in some of these planets, the observed methane levels are too high or too low to be explained solely by known geological processes, leading scientists to consider hypotheses that, until recently, were considered taboo. Although no one has officially uttered the word life, the presence of chemical compounds out of balance with the natural equilibrium of these environments represents an anomaly that cannot be ignored. The James Webb is forcing science to ask previously deemed too risky. One of the most baffling discoveries has been the abundance of well-formed galactic structures in surprisingly early eras of the universe. A chaotic scenario with constant collisions, misshapen, and poorly organized galaxies was expected. However, the James Webb's observations reveal a young universe that already exhibited massive clusters, stable spirals, and complex, precise gravitational interactions. Some astrophysicists are now openly stating that the Big Bang theory, particularly regarding the rate of the universe's expansion, may be based on incomplete data. It's no longer just about matter and energy. Talk is beginning to emerge of cosmic intelligence, deep design, and unknown laws. As the James Webb its observations, scientists have noticed another unsettling fact: the amount of infrared light captured is significantly greater than current models predicted. This not only translates into images with unprecedented detail, but also raises the possibility of detecting objects that, in theory, should be beyond the observable universe's limit. In other words, the telescope is capturing signals from regions of the cosmos that, according to current models, we shouldn't be able to observe. This idea challenges decades of scientific consensus, but cannot be dismissed if the data continues to accumulate. Cosmology may be facing a profound stage of revision, and the James Webb Telescope is at the center of this transformation. There is something in the images captured by the Webb that transcends the purely scientific. It's not just about distant stars or abstract figures, it's about what they awaken in us. Observing the universe with such clarity not only allows us to understand its origin, but also prompts us to reflect on our own existence, our smallness, our arrogance, and our need to understand something that clearly surpasses us. Each image captured by this telescope is not just a window to the past, it's a mirror. It shows us how far we've come, and at the same time, how little we know. It forces us to question everything: our scientific certainties, our cultural narratives, our conceptions of time-space life, and the origin of everything. Perhaps, deep down, that's what has truly stopped the world, not the data, but the feeling that something immense has just. The James Webb Telescope hasn't brought definitive, it has opened cracks in our understanding for granted.